am about to embark on a new and complex project. I'm planning to construct a storm shelter off the side of my basement. It's going to take a very long time, a lot of engineering, and a lot of planning and work to make it happen, and I will be posting updates. The shelter itself will be cut into this wall here. I will need to measure out the dimensions of the door and start cutting through the reinforced concrete blocks. This is off the side of my bunker home office. I will have to move all my equipment upstairs for at least a few weeks while this project is starting. Then I'm going to need to build a ramp, a wooden ramp, to go up to that window behind the green screen. At the other side of the window, which is about 14 feet below ground, we will need to construct a crane and a bucket to get all of the rubble out of here and to put it into a trailer or truck. This project is going to be enormously expensive and have zero return on investment. It's something that I wanted to do, and it should be fun. A new update. 4 hours later, we have the dimensions of the door for the storm shelter marked out and have cleared out all the furniture and equipment and papers and stuff from the basement. What we have remaining is covered with plastic. And now we are going to need to build the lift outside of the window to lift up all the dirt and rocks. Cutting the door part 1. Speeding up the video to save time. After carving the vertical cuts, it's time to chip the remaining concrete. Boy, did I get the jackhammer stuck. I still have so long to go. Finally, the opening in the wall is complete. Now it is time to cut the waterproof membrane and see what is behind the wall. At this point, I am fairly apprehensive because I do not know what is at the other side of the membrane. There could be water buildup, There could be a lot of loose rock. I'm not exactly sure until I cut it open. At this point, I see that it is pretty dry, and that's really a good sign because there was previously a lot of moisture going through this wall, and I was concerned that there may be plenty of water here, but it doesn't appear to be the case. As I continue cutting, I notice that there is a lot of hardened concrete that was poured along with the backfill gravel behind the wall, and that is something that I'm going to have to cut out. But nothing that can't be accomplished. After chipping through the backfilled concrete, the rock behind is coming into view. There are layers of shale and sandstone behind the wall. Very dry, but also very hard. Fortunately, I have the right tools to break it, although I wish I had some dynamite. Finally got all of the concrete out and starting to make some headway. Working on the storm shelter. Got a few feet excavated out. Putting it all in a pile. We finally started working on the elevator. The elevator is supported by two 6x6 pillars and one laminated beam made out of 2x10s. The beam is around 300 pounds and will support the hoist mechanism and the elevator cart. It's day 5 of the project and we have already tunneled about 5 feet. We sure are making a mess out of the basement. So we're running into some problems that have put us into a dead halt. Unfortunately, there is a little bit of water seepage. It's not a blocker, but it is irritating. We have run out of space for excavated rock and have to get the elevator working now. The power cord has started smoking and sparking, and I really need to replace it. The biggest problem is that the jackhammer has stopped working. A few of the bolts have come out, and I think some of the internal components broke, and I need to get that fixed. I am going to weld a mine elevator cart for my basement project. Using sheet metal and angle iron per the scale model that I created first. I am fabricating in my laundry room, so space is very tight. The new outlet is working very well. A lot of wonderful spicy amps. Elevator minecart fabrication. Part 2. Working on the door. We got it mostly done. Just need to drill a hole through the sides. And we'll put a rod through it so that the door can hinge on that rod. I now have the door set exactly where it should be. Little gap near the top where it pivots, and then the pivot rod is going to go right through there. I've been trying to set up the drill press, but having trouble. The spindle comes down not where I want it to pivot. I really want it to go there, but the base is in the way. Sometimes the best ideas don't go according to plan. It turns out I was able to reverse the press. We are in business. The first hole is done. Sometimes I feel just stupid. The 1/2-inch bit which I need to use is a lot bigger than the smaller one, and I need to raise this up. I do not have enough clearance. That's going to be a little bit of work. Back in business. And now it's done. I need to get better at mechanical design. This latch mechanism took me 5-6 different mental iterations and 8 hours of thinking before I designed it. But isn't it satisfying? The door latch will fit in this loop, and this eye bolt is adjustable in case I need to make it tighter or looser. I should be able to adjust these. I just got a lift. It was so heavy I almost couldn't get it up the stairs. This thing is huge. Look at the motor on this. I'm planning on setting it up like this, but I don't understand how. I hope there's some documentation. There is a user manual that comes with it. It doesn't have very much instructions, but the picture is a lot more clear, and I'm able to understand that this hook goes into this for the double lifting, which is somewhat unfortunate. I will need to balance my elevator cart on one lift point. What color would you paint DIY mining equipment? I just finished making this 150-pound mine elevator cart, and I'm about to sand it and paint it and get ready for installing it on a lift so that I can put it into production. Now it is sanded. It looks pretty good. Now it is painted. I chose black. You can have a concept in your mind, but until it's built and tested in the physical world, there's no way to know whether it will work or not. I hope this is going to be able to carry at least 1,000 pounds. We got the lift finally set up and aligned, and we're going to test it and see if it works. There it is, way down at the bottom of the shaft, and unfortunately this is... Now it is a third filled for a test. So far the hoist, cable, box, and main beam are all supporting the weight without any trouble. I think this is going to work well. There are a couple of minor kinks that need to be worked out before we can use the box. One is it is swinging a little bit and rotating in the shaft, which is going to be hard to control without some sort of tracks. And also need to design a hopper so that when the hatch opens up, that all the rock will dump into the bed of a truck.
I can't see it all. Even if I could, it'll all be great. Put your picture on my wall. It reminds me that it's not so bad. It's not so bad.
I am now going to try fixing it with this. So I'm trying to lift the collapsed beam today, and I'm doing it by myself. I set up a temporary crane in the attic with a steel bar which was tethered to a counterweight made out of cinder blocks. The steel rod rests on a 4x4 fulcrum and is already starting to bend from the weight. There's a pulley in the upstairs floor that is holding on to the beam, and then the other side of the rope is connected to the truck. I am also setting up counterweights on both sides of the beam to be able to lift it in place. I'm about halfway up. Right now I'm going to tie these to this cable really tight and lock it in place, and then drop down this counterweight to put a little bit more support on this side of the beam. An hour later, it is almost up. I just have 2.5 feet more to go, and that will be the hardest part. And now it's done. First test. Lost some of the load over the edge. Got a dumpster. Second test. Still having problems. Dumping on the ground. Going to fill in the dumpster. Third test. This time it's working perfectly. The brand new electric truck getting loaded. Dumpster is half filled. Dumpster is filled. So convenient. We notched out some of the concrete wall so that we can tie in the walls of the storm shelter with this wall. Rather than putting a footing, I'm going to support the wall with these pillars. So that's about 6 inches that will be filled with concrete, and then that will support.
The top panel shows a diagram of the block wall. It descends at 33 degrees and is supported by a pillar every 2.5 blocks.
That will support the block like so. Then the next block will go up like this, nice and level. And then we'll mortar those into place. I would like to do this, but first I need to fix my rotary jackhammer. I bought a part to replace the old broken second hammer. The dimensions are almost exactly the same except for the back side. I couldn't find an exact part number, so this is the closest that I could get. I think it's going to work. I removed the old grease. While I was cleaning this part, I noticed some steel shavings inside of the grease, so I gave it a good old kerosene bath, looking almost like new. Added some new yellow grease. After a lot of difficulty, I got it fixed and back together. It seems to be working. I still have to replace the cord, but I have a small job that I need to do first. For that purpose, I'm going to use my Corbett. Right here. This is actually quite difficult because if I go out of axis, even by a little, the machine will go out of control. And now they're both done. 13 feet of excavation is now complete. We are making good progress on the storm shelter and have excavated a second pile of rock. This is approximately 10 cubic yards, and we have a dumpster arriving tomorrow. I recently bought a brand new concrete mixer, and it is saving an exceptional amount of time mixing concrete for the walls. Unloading rock. Removing the second dumpster completely full. There is always a better way to do simple things. So I had a challenge of bringing a significant amount of heavy wood down from up here into the basement below. And so I set up these two side rails, and it makes it very easy for one person at the top to set the board into the rail and let it drop down. The other person in the basement can grab the board one by one. Very fast and simple. Crystalline silica. The fine dust released when breaking rock is a true menace when excavating a storm shelter. It lingers in the air and spreads throughout the house and settles on surfaces. I need to find a solution to this problem, and I'm planning to engineer a filtration system. Some of it did collapse today. A big chunk of rock from around here fell down overnight and collapsed onto the ground here. There's also a few more that are probably going to let go. I have to do some scaling and probably bolting as well. As an engineer, it is my job to solve geotechnical problems. If you're still laughing, then working below the water table requires constant water management. Here I've set up a small utility pump and a garden hose to pump water out of the storm shelter excavation into a settling tank. This is just a rain barrel that I bought on Amazon, and I'm using it to filter out any sediments in the water before it slowly drains into the main pumping station under this manhole cover. The spigot restricts it just a little too much. My yard cart conversion minecart has been working very, very good. Unfortunately, there is a weak link, and that is the bottom of the handlebar, and it broke right here at this joint, and it did the same thing on the other side. The handlebar is important because all the electronic controls are attached, and I will need to keep this top section intact, but I do plan to replace these bottom pieces with something a little bit more robust. To work on it, I will be unable to take it upstairs, up these spiral staircase, so I will need to work on it down here. I recently bought this 50-foot extension cord for my welder. Now it's plugged in. Got the rig set up, and now I just have to get the right amount of pressure here. So this fell down and this gauge got damaged, so I do have to bounce it a little bit. It is no longer giving an accurate reading, and I'm unable to get this to move, so I think it's time to replace it. I bought a new one at the welding supply store. I'm unable to get it off. It's too tight. Today I am fabricating a new handlebar for my broken self-propelled minecart. The cart is designed for 15% grade max, and I found I can increase that at least to 30% by pulling up on the handlebars while driving. This causes the tires in the front to get better traction but causes the handlebars to break off. Previously, the regulator gauge broke and I was unable to replace it, so as a backup, I'm just going by feel. Not too bad. I am happy with the progress. A storm shelter without walls is a sinkhole waiting to happen. A lot of people build the walls out of steel, but deep underground is a very corrosive environment, and the steel will eventually rust out and look terrible. So I prefer to use concrete. I like working with concrete blocks and mortar. There is nothing like the texture of a perfect mix of mortar. It is so soft, but will become hard enough to resist cave-in, and that is why I am now 25 feet below ground, and working conditions are getting slightly more difficult. I am well below the water table, and water is raining down from the ceiling. The rock is extremely hard, and I keep getting my jackhammer stuck. I'm trying to break it free with a much smaller jackhammer, but it is no match for the hard rock. This might be the deep slate layer. Over 30 feet of excavation is now complete. Another weekly update on the storm shelter. We are done with excavation for right now and will be concentrating on shoring the ceiling and completing the walls. We have been using an assortment of different sized jackhammers to complete breaking through the solid bedrock, and it has been working pretty well. Over the next few days, I plan to complete the air filtration and ventilation system. Elevator load number 99, dumpster load number 5 being removed. Big projects like building a storm shelter require a lot of heavy materials. This morning I got a small shipment from Home Depot, and I need to bring everything inside the house before it rains. Temporarily, I'm using a spare bedroom for storage, and I'm staging all of the material here, and will bring down to the storm shelter when needed. Now the room is full, everything nicely stored away. A proper storm shelter requires a lot of utilities. Today I'm installing all of the pipes and conduits. The green thin wall PVC is going to be for air ventilation, and the other pipes for different utilities. I need to do this before we can finish with the block wall on this side of the storm shelter. All of the pipes are on the outside of the wall and also outside of the waterproof membrane. And now it's done. This is how legends are made. Ooh, ooh, ooh. Ooh, ooh, ooh. This is how legends are made. Above it all, I need to run some electrical wiring to my storm shelter. I got some 14 gauge underground rated wiring. It should be perfect for running through the conduits. At first, the wire is feeding smoothly into the conduit, but as I start going further, it's getting increasingly tangled and twisted, and that is adding to friction, and I'm having a very hard time pushing it through. Let's start over again with some fresh wire. Now I'm rolling the spool as I'm feeding it through, and that's avoiding it getting twisted. I need to pull the wire through this T-section, but fortunately I have a specialized tool just for it. I just got back in town after a few days Christmas travel, and the storm shelter is filling with water. The water looks dark and terrible like sewer water. I better start pumping. I seriously need to get a new hose. Fortunately, the pump started right up without any issues. You know what? I'm fed up with adjusting this every time, so I'm going to use my backup wire cutters to cut this once and for all. Now that the hose is no longer obstructed with a kink, the water is flowing much more freely into the main central sump system. After an hour of pumping, the water level is dropping. 2 hours later. Now it's 8:54 and finally pumped out. Another weekly update on the storm shelter. We made a temporary sump pit at the lowest level for water to accumulate, and completed 2 of the block walls. I installed a second, smaller metal conduit for the light circuit. The switch box will be located right here. I need to reinforce the overhead rock with bolts and a ceiling. I have 3 possible alternatives for building the ceiling. The first is to keep poured concrete on a form, so create an arched form and then pour the concrete on top of that continuously all the way down. The second option would be prefabricated concrete sections that would be raised into place. And then the third is with concrete blocks. I need to install some rock bolts. So first I need to drill a few holes in the overhead rock over the storm shelter. This area is very important because it is the intersection of Phase 1 and Phase 2. I've had some issues with rocks coming down. And here we have my crazy homebrewed rock bolting system. Welded rebar and a grout pump made out of a rod and tube. On the one end is a funnel to fill with grout. I am using anchoring cement and a strengthening admixture. I wasn't able to get the grout tube all the way into the hole, so I just pumped as much as I could. Unfortunately, the rock bolt is not long enough, and I don't think I got quite enough grout inside for this to be truly effective, so I need to improve and iterate on the design. Just keep a last few taps. Surprisingly, after working for hours underground, the air quality is very high. 30 feet inside the storm shelter with no ventilation. The oxygen levels are exactly the same as they are upstairs. I wish there was a way to detect carbon dioxide because I'm guessing it's elevated like the radiation. We have started excavating a branch tunnel which leads to the entrance of Phase 2 of the storm shelter. Unfortunately, the rock in this direction is especially hard and the vibrations from breaking it are transmitting to the surface. Although we are 20 feet below ground, the vibration is quite significant and likely affecting the neighbors. We don't want any complaints, so I'm going to stop excavating in that direction for now. We've been accumulating rock in the sub-basement again since the ground outside is wet and muddy. I left my jousting pick in the corner and it got stuck like the sword in the stone. Eventually got it out. Getting ready to make a fresh batch of concrete. Falling rock is a serious hazard when working under unsupported rock when excavating a storm shelter. I am tapping on the rocks to identify which ones are loose. A lower pitch indicates that the rock is fractured. Technically, I should be shoring up the walls with bolts and netting, but I'm just keeping up on the rocks and making sure to scale off the loose ones. I can either use a long pick to break the rocks from a distance, or a handheld mattock to do it closer. I do need to be careful though because the rocks falling pick up velocity and can break bones. Yep, hazardous gases are always a concern when working in a confined space, or especially underground. I use this multi-gas detector to make sure that the air is safe for breathing, and it measures the concentration of common gases that you might find in a mine environment, including combustive gases, carbon monoxide, oxygen, and hydrogen sulfide. Any one of those can potentially suffocate you. Fortunately, all of the readings are very good in the storm shelter, so no problems here. I'm going to test it by filling the air with propane. And you can see that the carbon monoxide level is slowly increasing for some reason. I'm not exactly sure why, because propane should not be carbon monoxide without at least some sort of combustion. But anyway, the numbers are going up and the alarm is about to go off. There it goes. It's extremely annoying and you can't miss it. We're going bigger, baby. The new drill bit is longer and wider than the one that I was using previously, so it will enable a slightly longer rock bolt, and it should also be easier to pump with grout. The grout tube is fitting all the way inside, which is wonderful because I can pull down on it as I'm pumping upwards, and that will fill the hole evenly with grout. The bolt fits perfectly, and now all I need to do is put up some netting and a few more bolts, and the ceiling will be very strong. Today it is bright and sunny outside, but it's raining in the storm shelter. It's always raining in the storm shelter. Can't really be fixed, but it can be mitigated by pumping, and more pumping. At 22 feet in depth, the storm shelter is finally taking shape. We received a shipment of steel for my various fabrication projects and cut a 3/8 inch structural angle for the door lintel. Originally, I was going to build the ceiling of the storm shelter out of solid concrete blocks arranged in an arch, but I got a lot of comments in a previous video favoring a poured concrete ceiling instead. So I think that is a good idea, and we'll be doing that instead. For those that asked, this is a simple elevation that shows the storm shelter in relation with the existing house. I've been working on this project since August, and it's amazing how far we've come. I am preparing the tunnel roof for concrete pour. I attached some furring strips with the wrong type of anchor bolt and some fluffy concrete. I need to measure and mark any rocks that are overhanging and need to be cut. Before keeping plastic, I'm grinding off any sharp edges that might snag the membrane. Most of the sharp points are removed, and it should be smooth enough. And the plastic is in place, held by steel bands. My tunnel has a plastic membrane that I kept over the ceiling previously. Today I'm going to make a concrete form and suspend reinforcements on the plastic retention straps. The rebar is in place, as well as a wooden end cap for this segment. The concrete itself will be poured over top of a temporary steel form in an arch shape. To get the steel sheet into the correct shape, I'm using a pipe clamp and welding some support struts. Fortunately, my measurements were spot on and was able to slide the form right onto the furring strips. In order to expand the arch against the walls, I cut and expanded the support struts and burned off some of my hair. To cap off a day well spent, I brought a couple tons of concrete down into the sub-basement, staged it into piles, ready for mixing. This comment is exceptional. I was struggling to figure out how to get concrete over the tunnel form, and very likely I would not have thought of this method myself. After loading, the concrete is flowing nicely. I also got a good suggestion to use a Sawzall to vibrate the form. I'm using a massage gun, and it's getting all the bubbles out and causing the concrete to flow into place. My Amazon mixer is holding up and doing a great job. Mixed a little bit there. In total, the first segment required 2.5 tons of concrete. Now it is done. Ready for the next segment. I'm in a tunnel with 5,000 pounds of wet concrete over my head, and the only thing separating me from becoming a pancake is my own engineering. Last week I poured the first tunnel ceiling segment. Now it is time to remove the forms. I designed the steel arch form to be reusable. I just need to disassemble the wooden support structure and cut the cross struts. The form is detaching from the concrete better than expected. And now we can see the finish. Did you ever see dry concrete reflect like a mirror? Recently, I poured and removed the form for the first 8-foot tunnel ceiling segment. Painted and installed a lintel for the doorway. I got a new dumpster and have been getting rid of some of the rock that's been accumulating in my basement over the last couple of months. We moved 6 tons. Raised with my homemade elevator and put into the dumpster. As much as I love mixing yards of sackcrete, I'm thinking of getting some ready mix pumped in. Since it is always raining in the storm shelter, I don't really want to use blocks for the walls, and instead I'm going to set up forms around the perimeter and do a single pour with a line pump through the house. This should save some time and money. And look, I have more rocks. I have been working hard excavating in the storm shelter, and the rough dimensions are coming into focus. The ceiling is currently an arch or a dome shape, but I plan to run a steel beam across the middle here, and then afterwards I will cut out the corners. Under this board is the beta sump pit. We'll eventually hook that to the plumbing. The entrance ramp is there, and then I'm leaving an opening in the corner here for a possible expansion of the storm shelter. Today we installed a structural steel beam across the tunnel ceiling, but first needed to get it down into the sub-basement. I painted it a bit for protection. Before the tunnel wall is poured, the beam needs to be supported by the rock itself, so I'm drilling out a couple of pockets in which to insert the beam. Used a wooden 2x4 as a trowel before maneuvering the heavy steel beam. 200 pounds. Got it into position and had no trouble. I wrapped the ends in mylar to avoid corrosion. And now it's done supporting the ceiling. That's not going anywhere. I am building a secret tunnel under my house. As part of the excavation, an incredible amount of rock has had to be broken up and extracted. And I have excavated over 70 tons so far. Today I present to you the end-to-end workflow for removing all of the rock from inside the storm shelter. The first step is loading an electric minecart, driving it out of the tunnel into the main basement and up a ramp to the window. The minecart capacity is approximately 200 to 300 pounds, and at the other side of the window is an elevator that I designed. The elevator which hoists the load out of the window well has a capacity of over 1,000 pounds. Load number 129. After the truck is fully loaded, I drive to the front of the house where a dumpster has been dropped off. I drive the truck alongside the dumpster to make it easy to transfer the load. Unfortunately, the dumpster truck is too big and heavy to get behind the house, so I do have this extra manual step. I don't mind the work though, and it's not too bad. It's mostly mechanized. Previously, I installed a temporary steel beam across the ceiling of my tunnel. Since then, I've been doing a lot of excavation, preparing for the main storm shelter wall to be poured. Dumpster number 6 being removed completely full, dumpster number 7 being delivered. Today, I've been working on the water collection basin for the sump pump. I want it to be fairly large so that it can accommodate a lot of water and the pump doesn't have to run so frequently. Now it's all cleared out and ready for a concrete base. Since it is always raining in the storm shelter, I decided to use just dry concrete powder and mix it in the hole itself. Over time it will flood, but that's okay, that will just help it cure. Giving it a little mixing and tamping to give it a smooth finish in preparation for a brick wall. Now it is done, ready for the... I am in the secret tunnel and I was having a problem with vibrations transmitting to the surface, and I don't want to disturb the neighbors, so I'm going to be using demolition grout to silently break the rock, and I actually learned about this new technology from this comment right here. This particular layer of rock is the problem. It is very hard and monolithic and taking a long time to break with a jackhammer. So I got some Dexpan from Amazon on suggestion of a few commenters. First, I need to drill a few holes in the rock. The drill bit that I'm using is about 1 inch in diameter and it's a little smaller than recommended, but I should be able to do it with a few extra holes. Now I'm mixing the grout with a mixing paddle, and I pour the slurry into the holes. Come back to my page tomorrow and let's see how well this works. Just kidding. This is the next day and I can see that there is some cracking and I can hear internal fractures in the rock. It is still a lot of effort to break it up, but I would estimate that there is 70 to 80% less vibration and sound than without. I am almost ready to pour the walls of my storm shelter, but first I need to finish off the water collection basin. Today I'm planning on installing a brick wall for the basin. Unfortunately, since it's the lowest part and it's always raining in the storm shelter, water is accumulating as fast as I can mop it up. Highly technical problems require advanced engineering solutions, and I had just such a solution in this fluffy, cozy blanket. It worked as a super sponge and allowed me to finish the first row nicely. I seriously love bricklaying, but I'm not particularly good at it, so I jump at the opportunity to do things that are out of sight, such as the lining for this sump pit. Even Winston Churchill used to lay bricks in his free time as a relaxing hobby. I can see how that would reduce stress, and would love to do outdoor brickwork someday in the future when I'm a little better at this. I need to run a bunch of drainage pipes into this basin to collect the water here for pumping. Just finishing up the joints, making it look good. And now the first part is done, ready for the pipes. I have been making excellent progress on the antechamber of my secret tunnel. Previously, we carved out a water collection basin for keeping a sump pump and bricked all around the edges. I got a lot of feedback about the unhealthy levels of dust, so I got a better respirator. I fine-tuned the walls in preparation for concrete pour, and I filled dumpster number 7. Today I'm carving out a drainage channel which is going to be just outside of the footing for the walls, and it will keep the storm shelter dry. I laid down a perforated black pipe for drainage and poured some aggregate on top. for spreading plastic membrane on the wall. Now a large sheet of plastic is in place, held by some fiberglass rebar, which is secured with plumbing loops. Ready for more. I am building a secret labyrinth under my house. Today I'm working on the south wall and trying to get rebar in place. I'm having trouble with these wooden spacers that I designed, and I'm not able to get them to seat. It's time to fabricate a retention bracket. I am designing it as a continuous bracket with short segments of angle welded in place. I want plenty of space between the angles and between the wooden spacers because that's where the concrete pump is going to go. So far it's going exceedingly well, and the rebar is held by the spacers into a perfect arch with plenty of space between the walls and the future form. And now we have the reinforcement cage completed for the first wall.
The south wall is going to look beautiful.
I am in the secret tunnel, and today I'm working on a central pillar. I cleared out all of the soft and fractured rock to make a good foundation on which to build the pillar, and I drilled several holes for rebar. Since the holes are just for alignment and for keeping the rebar, I won't be putting any epoxy or grout. There are several utilities that need to go through the same space as the pillars, so I'm taking the opportunity to put them in place right now. I'm designing the concrete to support over 1 million pounds, so I'm not concerned about losing a little bit of strength with the pipe running through it. I got a lot of feedback on my previous video recommending that I use standard rebar wire, and although I thought I was being innovative and cool using the cable ties, this makes a lot more sense, and with a little bit of practice, it's easier and a lot stronger. And now the rebar cage is partially complete. I am building a secret tunnel under my house. Previously I had a problem where one of the walls cracked and the footing separated. Today I'm going to fix that problem by removing some of the fractured concrete and keeping a few dowels into the wall. The first step is to make a clean base and drill holes on both sides of the crack so that I can straddle it. My old Hitachi hammer drill makes quick work of it. A few months ago, I made a hand pump for grout injection when I was keeping rock bolts in the ceiling, and the same technique is working for this as well. I probably could have kept anchoring epoxy, but I'm not sure if that's rated for concrete to concrete structure. Now I'm inserting pieces of rebar to bind the wall together, and I will also tie it into the structural pillar that I was making a rebar cage for previously. This is the wall footing column interface where I'm going to surround with steel forms and have a few yards of concrete pumped in. And now it's done, follow for more. I tied 1,000 feet of rebar with 500 feet of wire to make the reinforced concrete walls and ceiling of my storm shelter more stormproof. And my hands are incredibly tired. Now that all the reinforcements are in place, it's time to make the steel forms. I punched a hole in the plastic membrane and installed a giant funnel for reasons. Wherever I had corners, I spliced in stainless steel angles. The entrance tunnel blockwork is going to interface cleanly with the reinforced poured concrete. The back corner is going to be an entrance to another and deeper and darker tunnel. The area beside it will be reinforced as well. I kept temporary wood supports until the concrete is poured. Pumping concrete into such an intricate space is going to be a challenge, and I'm planning to only pour half the arch at one time. In my regular basement, I accumulated a few tons of extra rock, but not enough for a dumpster yet. This problem is going to get solved today. I'm building a secret storm shelter under my house, and an issue that I've had since the very beginning is groundwater and having to pump it out manually all the time. Now that I have a proper pump, I need to connect it to the discharge pipe, which I already buried alongside the main tunnel. I had an unexpected setback and had to come back with a respirator for chemical cleanup. For maintenance purpose, the discharge pipe is going to go through the wall, be exposed, and then drop down under the slab. I laid the pipe in a channel that is going to be filled with gravel with the slab on top. It's not quite deep enough, and I may need to redo it. Temporarily, I'm just pumping into a collection barrel. On testing, the pump is working great, and the flex seal is holding. This check valve is a piece of junk. Earlier, I installed a sump pump in the secret tunnel, and there were a few details that I'm not too happy about, so today I'm going to redo some of the plumbing and do a better job. First up, I bought a brass check valve with a much larger orifice, which should put less load on the pump. Also drilled a weep hole below the check valve to avoid airlock, and added a union to make it easier to disconnect the pump for servicing. The head will be about 25 feet, so want all the connections strong. The discharge pipe is going to drop underneath the storm shelter slab, and previously I installed it not quite deep enough, and I don't want to fuss with it when I'm pouring the concrete, so I'm making the channel just a little bit deeper and being very careful not to disturb the nearby footing. Now it's all carved out. I'm also laying a short section of conduit for the power cord of the sump pump to go under the slab. In the regular basement, I'm going to tee into the existing discharge for the house. No! As I was fiddling with the pipe, it broke in the wall above, and I had to cut into some of the drywall to make an emergency repair. Now all the plumbing in the basement is complete and the new pump is connected to the existing riser. Meanwhile, back in the tunnel, I got all the pipes in place and now it is ready to pour some gravel on top. And now it is fully done and the job is looking pretty good. I'm building a secret tunnel. Don't you think it needs a steampunk mechanical system? Previously, I made a frame and housing for a variety of filters for my air scrubber. My last video got some good feedback, so I'm using a bolt as a handle. Now I'm attaching a mounting bracket. Unfortunately, I forgot to drill the bracket before mounting it, so I'm having a lot of trouble getting enough leverage. I didn't want to lose the Tin Man aesthetic, so I'm using clear Rust-Oleum paint. Now that the body is attached to the ceiling, I need to connect a blower motor and a duct to attach to the tunnel ventilation pipe. Now it is running and you can see how the damper allows me to control the airflow inside the tunnel. Inside the scrubber box I can replace filters, and in the tunnel itself I'm getting ventilation. First time. I am getting ready for pouring the walls and ceiling of my secret tunnel. Earlier, I set up a rebar lattice and ordered a truckload of steel sheets. I am building the forms out of steel as I can design intricate shapes and avoid concrete leaks during pumping. The steel is not strong enough by itself, so I will add some wood supports later. It is tricky keeping a gap away from the rebar. Ideally, there should be 2 inches. I developed a technique to scribe the pieces without measuring using a string and magnet. Here, I'm using a strip of steel to simulate the curvature of the ceiling arch and cutting it with my angle grinder. Let's see if it fits. Absolutely perfect. No adjustments needed. I am only tacking the seams as I will remove the steel after the concrete is poured. I am almost done with half the main arch. Follow to see the big pour. I am building a secret chamber under my house and have been diligently working on the steel forms for the concrete walls and ceiling. There are a lot of intricate aspects that need to be considered before the concrete is poured, such as all the utility pipes that are going to go through the wall. I kept foam sheaths over each of the pipes to keep them from breaking when the concrete settles. I bought a plasma cutter that was on sale on Amazon Prime Day. It should save a lot of time cutting steel. There was a fire and a flood that set things back a little bit, and the fire extinguisher dust is really corroding the steel. After a bit of repair work, we are now back on track, and I'm ready to install a wooden support system to get ready for the big pour. Follow to see it. Previously, I installed steel forms for the walls and ceiling of my secret tunnel. Now I'm reinforcing them to support 12 cubic yards of concrete. Made a whole lot of these precision engineered brackets. And I'm welding them to the steel form to support wood. This is what it looks like through the welding helmet. Once the brackets are in place, I am able to attach lateral wooden supports. The horizontal supports are just a start. Each of them needs to be supported by struts and vertical pieces because the concrete will weigh dozens of tons. I need to be double, triple careful not to start another fire. That would be very bad. Now the concrete truck's just rolled in and it's time to put it to a test. It's done. Removing the concrete forms from my secret tunnel. Part 2. Now it's done. Time to go to the movies. removing concrete forms from my secret tunnel.